Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this session I'm working on z-test. In our previous sessions in hypothesis testing, we have worked on the right tail test, left tail test, and two tail test. Now you are learning how to use the z-statistics in hypothesis testing, dear students. Okay, in our scenario, we have an e-commerce company publicly claims that their average online order fulfillment time is 48 hours. Instead, that the standard deviation is 6 hours, calculated from thousands of past orders. A new logistic manager, however, suspects that the company may not be meeting this standard anymore. Orders might be fulfilled faster under the new system. Okay, dear students, in this situation, the general fulfillment time, order fulfillment time is 48 hours, but the new logistic manager is just claiming that because of the new system, there is efficiency, right? So now this claim that the new logistic manager is having a claim that now the company is providing or fulfilling the order in less than 48 hours. For this purpose, the sample of 36 situation is just taken, right? And the order fulfillment time is given for each. Okay, but keep in mind, dear student, in this example, the standard deviation is known. Why? Because the 6 are calculated from thousands of past orders. I mean, this is somehow constant. So that's why we say the population standard deviation is known. And you know that in this z statistic, when the population standard deviation is known, then we are using the z statistic. Okay, we have a data. First you should compute the mean value, which is the average. Take the standard average of all the value we have, and then the next you should have the significance level. Okay, in our hypothesis, dear student, the null hypothesis, we have the mean time is greater than or equal to 48 hours, but the new manager, logistic manager, is claiming that no, the new system is now providing the efficiency, right? So the order fulfillment time is less than 48 hours. For this claim, you must have what is your significance level just to test. So significance level is 0.05, and the critical z value for 0.05 is 1.645, dear students. Okay, now what is the z value? Just use this function. In this function we have x bar, this is the mean value, and minus the mu. Okay, this is mistakenly we have 50 here, this is mu. Okay, the mu is this, the hypothesized value is 48, so 48 is mu, should be divided by the sigma, which is known, which is 6, and this should be divided by the square root of the sample, and the sample is 36 in our example. Okay, okay, now the z value is minus 1.71. Since the z value is less than the critical z value, we are rejecting the null hypothesis. Why? Because we are proving that the mean value less 48 or this is true. Okay, why? Because the z value is less than the critical z value 1.645. Okay, if you just try to find out what is the p value here, okay, just go into the table and check 1 minus 1.71. So the t value we have here is minus 0.7, 1.7. This is minus 0.7, minus 1.70, and this is minus 1.71. So this is the p value here. Here is 0.043, 0.043, dear students. So you can say, since the p value is less than the significance level, you can say like this: since the p value is less, the p value we have is 0.043 is less than significance level, significance 0.05 level, then you can say, okay, sorry, then we reject the null hypothesis, right? Why? Reason: because the p value is less than significance level, and also you can say the z value is less than the critical level. So you can compare these two, or you can compare the significance level and the p value in this situation. Hopefully, dear student, this is clear. Assalamu alaikum wa rahmatullahi wa barakatuh.